Hello guys, welcome to the C++ tutorial series. In this video, we will learn about smart pointers in C++. My name is Kafui and welcome to my channel Mortdotdev. Please subscribe and like to help the channel grow and turn on the bell notification icon to get notified whenever I release a content on the channel. With that said, let's dive in. Smart pointers are pointers that own the object they point to and automatically destroy the object they point to and deallocate the memory once the pointer goes out of scope. With this, we don't have to manually delete the object, which was the case with the new and delete operator. Thus, when we want to work with raw pointers, so I'll just go ahead and then declare a raw pointer called p, and then using the new operator, I'll initialize this to 100 and terminate it, and then I'll declare another variable, say p value, and then assign it to the dereference of what the p pointer, and I can go ahead and then output the value of p, which is p value, out to the console. And when I run my code, we get the value at 100 outputted. But upon doing this, I have to remember to delete the pointer after using the delete operator, which is the pointer p, in order to deallocate the memory I have assigned to this pointer using the new operator. So I'll go ahead and run my code again, and I get the value. So the value of p, or this pointer, is available to this main function from the start of the curly braces to the end of the curly braces. So with using the delete operator, I've deleted this pointer before, as it has gone out of scope. So that is it with the new and delete keyword. Now the first smart pointer we'll talk about is the unique smart pointer. And before we talk about the unique smart pointer, it is a pointer that owns an object it points to, and this pointer cannot be copied. So in order to declare a unique pointer in C++, we have to first include the memory header into our code. So I'll go ahead, include the header file of the memory, and then I can declare, let me just go ahead and then delete all this here. I'll go ahead and then declare or define a unique pointer using the unique pointer from the std namespace, and then I want an integer pointer. The name of my pointer should be p, and then assign it to the std namespace, the make unique function, and then in there I'll put in the integer variable and then assign it to the value of 100. So by so doing, I have declared a unique pointer. First, you have to include the memory header file into your code, and then from the std namespace, using the scope resolution operator, you access the unique pointer, and then in angle braces, the data type, in this case, which is an integer, the name of your pointer, in this case p, and then you assign it to std namespace. Using the scope resolution operator, you access the make unique function from the std namespace, and then in angle braces, the data type of the pointer, and then finally you initialize it with a value. So in this case is 100. So this is how you can create a unique pointer or declare a unique pointer in C++. Now I can go ahead and then output the value of this pointer. So I'll just say std cout. I'll dereference it, and then before outputting its value, when I go ahead and run it, we get 100. When I don't dereference it and I try outputting it, we get the memory address of the pointer outputted. So this is the memory address of this pointer. So when we declare pointers using smart pointers, for instance the unique smart pointer, this pointer gets destroyed and then the memory gets deallocated once the pointer goes out of scope. We don't have to use the delete keyword to delete this pointer. Now the next pointer we'll talk about is the shared pointer. So the shared pointer, let me comment this out. The shared pointer can have multiple pointers to a single object. In that case, we can say that all of them own the object they point to. So let me just give you an example. And in order to declare a shared pointer in C++, you still have to include the memory header file in your code. So I'll go ahead and declare it using the std namespace. I'll access the shared pointer, and then in angle braces, the data type, in this case, which is an integer, then I'll just say pointer 1 or let me just say p1 for short, and then assign it to the std namespace. Then using the scope resolution operator, we access make shared function, and then in angle braces we have to put in the data type, and then finally the value. So I'll just go with what, 200 here as the value. So this is how we can declare a shared pointer in C++. So by so doing, I can go ahead and then std cout. I have to reference the pointer before I can output what, its value. When I go ahead and try outputting the value, I get what, 200. So what we can do is that since this is a shared pointer, many objects can point to what, this pointer. So I can go ahead and then declare another pointer to this shared pointer. I'll just say shared, and then in angle braces the data type, which is an integer, I'll say p2 for short, and assign it to what, p1. And then I'll just go ahead and declare another one, std shared pointer, which is also an integer. I'll say p3 for short, and assign it to what, p1. By so doing, p2 and p3 are what, references to what, this p1 pointer, and they are shared pointers, and they are all referencing the same object in what, the memory. So I can go ahead std cout, and then I have to dereference them before I print out their value. So I'll just copy this down. I want to print out p1, p2, and then p3. Change this quickly to p3, and change this quickly to what, p2. By so doing, let's run our code and see the values. So we get 200. Let me just print a new line after this quickly, and then go ahead, print another new line using the new line character. Now run my code. So we should see 200 outputted in the what, console. So we see 200 outputted in the console. So this is how we can declare a shared pointer in C++. With this, all these pointers are what, pointing to what, the same what, object in what, the memory. And then this pointer gets destroyed automatically, and then the memory gets deallocated automatically as they go out of scope. So you should note that in C++, you should prefer smart pointers over what, raw pointers. So that is, we should prefer declaring pointers with the shared and then the smart point, the shared and then the unique pointers than using the new keyword to what, declare pointers in C++. That's it for this video on smart pointers in C++. If you have any questions, put them in the comment section for discussion. Thank you for watching, and see you in the next one.